The next question from CSIR net mathematical science, question number 41, 2018 December. Here the question from partial differential equation, and mainly the question from D'Alembert principle. Also we can use to solve this by Laplace transformation. Here the question is uxt be a function that satisfy the PDE uxx minus utt equal to e to the power x plus 60, x belongs to R, t greater than 0, and the initial condition ux0 equal to sin x and its derivative ux0 equal to 0. Then this is then u pi by 2, option 1 is this, option 2, option 3 and option 4. So you use to solve this question by Laplace transformation. Here uxx minus utt equal to e to the power x plus 60. So we take both sides Laplace transformation, then L of this, L of this, and L of this is, and L of this. Here e to the power x, 6 all are constant. We use Laplace transformation of t. So here x is constant. So this is now del square u bar del x square, L uxx equal to del square u del x square minus L utt is equal to s square u bar minus s u x0 minus ut x0. This is formula. Utt, L of utt equal to this, and RHS is same. Now we also here this is actually L e to the power x L1, and this is actually 6 LT. Now the next line, del square u bar del x square, sorry, d square u bar dx square minus s square u bar. We multiply this from minus sign, then this is plus, and also here given that ux0 equal to sin x and its derivative is 0. So this term is vanish, and here we know that what we know that L of 1, this is equal to 1 by s. So here put 1 by s, and L of t equal to 1 by s square. So here 6 by s square. Now u bar equal to, now here we common d square dx square is capital D square minus s square u bar equal to minus s sin x plus e to the power x by s, this is s, and plus 6s square. So now divided both sides by d square minus s square, then we get this, and here is this and this. Now we calculate u bar. Now here sin 1 into x, we know that sin ax, then we put d square is equal to minus a square. So here d square equal to minus 1 square, then minus minus cancel out, then we get s square plus 1 sin x, and here the coefficient of e to the power x, here e to the power 1 into x, and put t equal to 1. So this becomes, so this becomes this, that is e to the power x s 1 minus s square. Now here we suppose this is 0 into x, so e to the power 0, so this is 1 value. So here we put d equal to 0, so this becomes 6 by s to the power minus 4. So 6 by minus s to the power 4. Now u bar is s by s square plus 1 sin x, and here if we calculate this, a by s plus b by 1 minus s plus c by 1 minus s, then finally we get this. So we get 1 by s minus 1 by s plus 1 plus 1 by s plus 1 by 1 minus s. This term can be written as this, and also this is same, right? Now uxt, how we find uxt? We use inverse Laplace transformation. Then sin x are fixed, and this L inverse, this is equal to s by s square plus 1, this is equal to cos t, and e to the power x by 2 fixed, and here 1 by s and also 1 by s. So L inverse 1 by s plus L inverse 1 by s is 2, this is 1 and 1, so 2, and this is e to the power t, and this is e to the power minus t, and this is t to the power 4, right? Now here given u pi by 2 pi by 2, so put x equal to pi by 2 and also t equal to pi by 2, and this term is 0 since cos pi by 2 is 0, and this term remains. So we put x equal to pi by 2, then we get this, multiply both side e to the power pi by 2, multiply the term from third bracket e to the power pi by 2, then we get this. Now common here and here, pi by 2 e to the power pi by 2, then we get 1 minus e to the power pi by 2 by 2, and this term and this term we write here and take common minus, then we get this. So finally option 3 is correct and the other option is false.